We're going to show now that in a principal ideal domain, remember this is a ring, a commutative ring with one, such that every ideal is generated by a single element. In such a ring, in a principal ideal domain, every non-zero prime ideal is maximal. This is our lemma for this mini lecture. So let R be a principal ideal domain. Every ideal is generated by a single element. And let I be an ideal which is unequal to 0 and which is prime, then our ideal I is maximal. Okay, proof. Well, since every ideal is generated by a single element, we can write I in the following form. I is this. I is generated by an element x. And now suppose that I is properly contained in another ideal. Then we need to show that this other ideal is necessarily the whole ring. Then we have shown that. Then we will have shown that x, the ideal generated by x, which is I, is maximal. So if there is an ideal J properly containing I, then we can write this ideal J in the form J is the ideal generated by a single element Y, and this now contains this element, this ideal generated by X. So X is now in this ideal generated by Y, which means that we can write X in the form A times Y for some A in our ring. And this implies that, or says that A times Y is an element of the ideal generated by X, because it is X, as we have just seen. So now look, Y is by assumption not in X, in the ideal generated by X, but this product is in the ideal generated by X. So by primeness of the ideal generated by X, we have that A must be in the ideal generated by X. So A is in this ideal since this ideal is prime. And this means that we can write A in the form X times B for some B. In R. And now we can plug this in up here. So we have X is equal to X times B times Y. So we see that B times Y is equal to 1. So y is invertible. And this, of course, implies that the ideal generated by y is our ring. And this concludes the proof.